In this video, we will have the last lesson on differential calculus. At least that is from my experience. The coverage was until this topic. So we apply the concept of chain rule in partial differentiation. And there are two categories. So one that involves one variable only, and the other involving two variables. So let's start first with the more simpler version. So when we say one variable, typically the formula looks like this. So dz over dt is equal to partial z over partial x times dx over dt plus partial z over partial y times dy over dt. So that's how the formula typically looks like. Let's have an example. So we have 4x squared plus ln y, and we are given, this is what makes partial differentiation involving chain rule unique, because we are given extra information, namely x is going to be sine t and y is going to be cosine t in this example. So what do we do with those two details? So we are supposed to find four things based on this formula. Sorry. So this, actually wait, this, and this. So for starters, partial z over partial x, we are going to render the y constant, right? So we only have x and y as the variables. So since x is in the denominator of our notation, the other variable that's not mentioned, which is y, is going to be considered a constant. So we're going to have 8x. This ln y is going to be 0. So just 8x. Partial z over partial y is equal to, we're gonna consider x as constant, right? So 4x squared is gonna be 0. ln y becomes 1 over y. Partial z, what else? Partial x. This I'm not sure. If you're supposed to write d this way or that. I'm not really sure. Anyways, it's just the writing, but the idea on how to solve it remains the same. That's what I'm teaching you. So partial x over partial t is equal to, in this case, we're going to involve this. So the derivative of sine t is going to be cosine t. That's basically it. And partial y over partial t is the derivative of this. So cosine t negative sine t. So now that we have these four terms, dz over dt is equal to partial z over partial x, which is 8x, right? Times dx over dt, which is cosine t, plus partial z over partial y is 1 over y, times dy over dt is negative sine t. So 8x cosine t minus sine t over y. After that, this is where we make use of these two. So earlier, we found their derivative, their corresponding derivatives. This time, we're going to substitute. So 8, and then x is sine t, right? So 8 times sine t cosine t minus sine t over, what is y? Cosine t. Or we can rewrite this answer as 8 sine t cos t minus tan t. So this is the final answer. What's another way of solving it? Let's try this method. So let you express z as a function of ft. So z is equal to 4 sine t squared plus ln cosine t. So you basically substitute x and y respectively. And so you find dz over dt. How do you do that? So power rule, 8 sine t raised to 1, derivative of sine t is cosine t, plus 1 over cosine t times derivative of cosine t, which is negative sine t, times 1 or none at all. So this time let u is equal to sine t, u squared equal to sine squared t in that sense. So this is where it gets relatively confusing, so try to figure it out. 2u times du over dt is equal to 2u cosine t. I guess this is just an optional solution. You already know how to solve this based on what I taught you earlier. This is just an extension. Okay. It's final. This is kind of messed up, but this is a good solution. Let's try another example. Z is equal to x squared minus y squared, such that x is 14t squared minus 1 and y is equal to 2e raised to t. We're doing two variables later. Just one example. It's pretty lengthy. So partial z over partial x, partial z over partial y, partial x over partial t, partial y over partial t. Here we're going to render y constant. So y squared times 2x times 1 or none at all. Partial x over partial y, x is gonna be constant. So set aside x squared and then times 2y. Partial x over partial t is 28t, derivative of this, and this one to remember, d over dx e raised to x is equal to e raised to x times derivative of x, which is just 1. Same concept actually. You set aside the constant and you apply this. What you get is the same thing. So after that, let's compile. So dz over dt is equal to 2xy squared times 28t plus 2x squared y times 2e raised to t. And this is, we don't stop here. we substitute, and this is where it gets a little lengthy. 2 times x is 14t squared minus 1, right? And then y is gonna be 2e raised to t squared times 28t plus 2 times 14t squared minus 1 raised to 2 times 2e raised to t times 2e raised to t. Whether you like it or not, we have to simplify this. So, how do we start? Uh, What's 8 times 28? 64. 224. Okay. Simplify this. That's gonna be 4e sorry, 4e raised to 2t. I think that's how it is. 4 times 2, 8. 8 times 28, 224. 224. Let's just simplify this already. I'm not sure, but I can assure you this solution was verified by my professor. I'm just not sure how these could be put together. But essentially how it goes... Oh, wait, sorry. 224t e raised to 2t, okay. And then times quantity 14t squared minus 1 plus, let's make it 8e raised to 2t times quantity 14t squared cube. This is supposed to be squared. At this point, I think it's appropriate to use a calculator, even though traditionally it's not permitted. Let's just get through it. I'm teaching the concept, not how to solve large numbers. We're gonna take so much time. That's the thing. So, distributive property. You expand this. So what you get is 196t raised to 4 minus 28t raised to 2 plus 1. The final answer would be 3136t cubed e raised to 2t minus 224t e raised to 2e plus 1568t raised to 4 e raised to 2t minus 224t squared e raised to 2t plus 8e raised to 2t. Voila. Okay, we're done with one variable. This time, let's have an example on two variables. Let's try z is equal to... Wait a minute. Okay. 4x squared plus ln y. It is the same thing, but for x we have s sine t plus e raised to 2s. For y, we have cosine t minus s squared. Uh, the formula typically for the one involving two variables is this. dz over ds is equal to partial z over partial x times partial x over partial s plus partial z over partial y times partial y over partial s. So try to compare the difference between this formula from the one variable and the one that I just wrote. So go figure. It's wise if you are familiar at least with the formula, so you know what to do in the exam. So let's continue. We have to look for, this time, actually six things. So you have to look for partial z over partial x, partial z over partial y, as usual, partial x over partial s, partial y over partial s, partial x over partial t, partial y over partial t. So I believe this is the new pair that we usually solve for when we have two variables. These four, we're already familiar to them so far. So let's see how they'd be used later. So now, here y is constant, right? So 8x, same concept. Here y is constant, so 1 over y. In partial x over partial s, t is gonna be constant. So don't be confused, it involves this. So I believe we are going to... Okay, sine t is a constant technically. And derivative of s is 1. And then plus e raised to 2s times 2. Or 2e raised to 2s. Here, t is also constant. So cosine t is 0. Negative 2s. Okay, that's it. Partial x over partial t, this time x is gonna be constant. So s cosine t, that's how we do it, times 1. So it's just s cosine t. Okay. So negative sine t. Here. So now let's look for dz over ds. So that is partial z over partial x times partial x time over partial x, which is sine t plus 2e raised to 2s, plus partial z over partial y times partial y over partial s. Then now let's substitute. What is our x? S sine t plus e raised to 2s. And then just copy. Y is cos t minus s squared. And then we simplify. apparently dz over ds. So that's what we found for dz over ds. This time we look for dz over dt, and that's basically partial z over partial x times partial x over partial t plus partial z over partial y times partial y over partial t. Then substitute. I think this is what we continue with. I don't get why we had to do this at this point. I can't really remember why. So that's it. That's basically it. We are done with differential calculus officially. So here are a few more sample problems. I'll just show you by camera. So this is one. This another one is this, although the answer is unchecked. Here it's not complete. It is pretty long. This was the example from earlier, as well as the one above. And this is the solution that we just did now. So that's basically it. Thanks for watching.